Accessory bus options. That's what we're looking at today. I said earlier, it's quite a large subject, so I've broken it into two. Today we're looking at what's available commercially, although a couple of Merck products along the way, but largely commercial systems. And then in 2 weeks' time, we'll look at part two, what Merck has got to offer in terms of bus systems. So I suppose we ought to look at what we mean by accessories and what we mean by bus before we look at all the options. We're going to compare various methods of controlling them, and along the way I've broken into two things: the facts and the pros and cons of each. The facts are taken from the documentation, so we can argue with that if we like, but the pros and cons are obviously subjective. So I can put down pros and cons, and you'll find sometimes I'll have the same item in both the pros and the cons. For example, if we're talking about using computers, to some people that's an advantage because they've got flexibility. To other people it's a disadvantage because they hate computers and don't know how to work them properly. So it depends on your point of view whether it's a pro or a con in that particular regard. So there are my pros and cons, and we can discuss them in the discussion session. The accessories are, as you see there, lights, sound, points, uncouplers, animations, all the kind of things, everything, in fact, that's not traction. Everything that's to do with the layout apart from the actual movement of locos. Having said that, some of the systems also support traction. But we're looking today at the control of accessories using a bus. What do we need to look at? Functionality. Well, because there's quite a wide range of choices, you can pick what you want to do. It depends what you want to achieve. Do you only want to have various lights? Do you want to operate servos? What kind of features do you need? So you'd have your own shopping list of your needs, and you can see then whether any particular system fits in there. So we'll look at that along the way. Ease of setup. What I mean by that is, does it come as a kit? Does it come out of the box? Do you have to build it? What's involved in configuring it all? Is it easy? Is it complicated? Does it involve 10,000 button presses that involve a computer? Or does it work straight out of the box, and so on? How easy it is to get it established? And once you've got it established, how easy is it to use it? Is it something you see on a screen? Is it something you have to memorize what button to press or whatever? Bidirectionality is a big word. Do you want to be able to send commands to do stuff, but also get information back? I'm thinking of things like train detectors lighting up your control panel or what. Do you want the messages to go in both directions? Or are you quite happy to throw a switch at one end and something happens at the other end? Fault handling. Different systems are easier to maintain if things go wrong than others. And also the cost, of course. And we're looking at commercial systems first. So as you would expect, they're going to cost more, but generally speaking, you've got less work to do. And also along the way, when you're choosing which one, you've got to decide what controls you want to use. I mean, conventionally, there's control panels with switches and push buttons and lights and so on, or some people use lever frames to operate points. Are you happy with that system? Or do you want to have everything controlled from your DCC command station if you're a DCC user? Do you want to have a wired handset, the kind where you can have something in your hand and you control it here, and you have a loop of wire that takes you to the layout so you can walk around the layout to a certain extent? Or taking it further, do you want it to be remotely operated? via Wi-Fi, using your phone or using a tablet or whatever. Or do you want a permanent glass panel? In other words, a computer screen where you can click on items on the screen, or computer controlled. It's all automated. So it depends. Certain systems lend themselves better to the various options there than others. So we'll look at those along the way too. So before we look at buses, that's the existing system that most people have. They've got a control panel somewhere with switches and buttons, and for every little point or every little light on the layout, they've got separate wires that run to them. I mentioned earlier that I visited a member's house and he's got 140 points alone. So it's 140 sets of wires routing from the control panel all around the layout. And the layout is 40 feet by 40 feet. So you can imagine the amount of wiring that's involved there. And on top of that, he's got sound effects, he's got lights, he's got signals and so on, uncouplers. So the sheer amount of wires that have to run between the panel and the accessories is huge. And then if you take into account you want feedback, in other words, not just sending things from the switch to an item, but an item itself sending data back. You've arrived at that point, a train detector lets you know. That's even more wires into the mix. And that's the traditional way of doing it. Huge wiring looms between different boards and so on. The benefits of keeping this system are that it's easily understood. You throw one switch here and something happens over there. Another switch operates something else, as simple as that. So easily understood how it operates, and therefore also easy for fault finding. You throw that same switch and nothing happens over here. Then the problem is either that switch, that gadget, or the wires in between, or the power to it. So fault finding is relatively simple in those kind of situations. What's the downside? Lots of wiring, like I said, huge amounts of wiring, and it's a one-way system. You can have a bit of wire that goes from A to B to put a light on. We need a separate wire that goes from C to D to let you know of train detection. And like I mentioned earlier, the pros and cons can be the same. I've said easy fault finding and hard fault finding. It's easy fault finding in the sense that you know that A should operate B, but it's hard fault finding in the sense if you haven't properly documented your layout and you're trying to work out what bit of wire went from where to where to where to where as it goes between different plugs and sockets on its merry way along the layout. So it can make it difficult to fault find in that situation. Because of that, it's become more common to move on to bus systems. Instead of having multiple wires, a couple of wires run around the layout, usually two, sometimes more, but usually two wires, apart from the power, run around the entire layout. And they handle all the switches and whatever, and they handle all the accessories on those couple of wires. That's what it looks like. You've got a pair of wires, and then you've got inputs that can connect to that bus, and you've got outputs from that bus. So you can have switches, all kind of inputs here. For example, we could put a switch on to pin 1 here, and it would send a message along to here to operate output 1, which could be lighting a LED. So although there's 8 different devices here and 8 different inputs here, they're sharing the one pair of wires. I could add another input and another output, and have 16 inputs and 16 outputs. I could have 40 inputs and 40 outputs. I could have 100 inputs and 100 outputs, and they will still share the same two pairs of wires. So instead of having individual wires running between inputs and outputs, we actually have to send messages. So you throw switch 3, you send a message, by the way, I've thrown switch 3. Oh, have you? In that case, I'll put on lead number 3. That kind of idea. It's all messages round the layout on the two-wire bus. What do we need from a bus? Well, I said 2 wires generally, sometimes more, but generally a 2-wire bus. And we would prefer it to be a 2-way bus. So we can have LEDs on a panel with totties operating them or something similar. Ideally, taking power for accessories from your standard 12-volt supply. You can take it from the bus, but it's not recommended generally unless you're just putting 1 or 2 on it, because you end up overloading the bus. It's got to supply both the traction and every accessory. So in my example of the friend with 140 points plus all the other accessories, you can imagine the amount of power you'd have to take out your DCC command station or whatever. The other requirement for a bus is you're going to send messages. You need some kind of controller to send those messages. And that's where we look at different bus systems. They use different types of controllers with different types of messages. The benefits of having a bus: there's less confusion on documentation. There's fewer wiring faults because there's fewer wires. Fault finding can be easier because if something goes wrong, you only have a problem in one section. You've got a common bus. It may have 8 modules on it. If module 5 breaks down, you know where the fault is. It's in that particular module. And you don't have any problems with multiple plugs between boards, especially when you're going back and forward to exhibitions with layouts, where there's constant plugging and unplugging and making bad connections. You've only got the 2 wires for the power and 2 wires for the bus. And very handily, because we're always changing our layouts, it's easier to make changes and to add things. You simply put another module onto the bus. You don't have to add any extra wires. You just get a module, take 2 wires to connect to the bus, 2 wires to connect to your 12-volt supply, and you're good to go. So it allows easier alterations to your, or additions to your layout. So there's a lot of benefits to the bus system. Today we're looking at using the DCC accessory decoders, and then the DCC concepts board, and the new Megapoint System 2 board, which are all commercial ones. And then in part 2, we'll look at the 3 main offerings from Merg: the peer-to-peer light, EasyBus, and CBus, with their different pros and cons. So let's start at the beginning. What do they offer? Well, we said we want to do these things. They all the bus systems, commercial and Merg, handle lights, of course. They all handle, or some of them handle sound. Some of them handle service, not all. Some of them can do semaphore bounce, not all. Some can handle solenoids. They can all do it if you add on extra modules or extra circuitry. We can make any module do anything with a bit of circuitry or additional modules. But there's others, like getting feedback. Only some of the variety of buses allow feedback. I'm not talking about totties here. I'm talking about feedback that lets you know that a signal has arrived or an operation has taken place. And same with reporting. Only some of the systems will do reporting back. Like you hit a button and it'll tell you what modules are connected, for example. You throw a switch and it'll tell you what signal it sent, that kind of thing. So generally speaking, the last two, you can't really get round easily with additional modules and circuitry. You either support it or you don't. Right, let's start with accessory decoders. Its good point is there's nothing to do. If you're a DCC user, you already have the bus. It's called your track. The track's already carrying the messages to your locals. Then we can simply tack on to that anywhere along the track an accessory decoder. And now it can receive messages. Whereas all the other systems require an added bus to carry the messages. Accessory decoders are sometimes called function-only decoders, or sometimes called stationary decoders, essentially the ones you don't put into your locals. They're not intended to have traction and pulse width modulation and so on. They're only meant to handle accessories. Handily, the size is less important then because you're not trying to fit it into a local. It can be under the layout or inside a building or whatever. And they all operate in the same way with DCC using function numbers. You hit function key 9, that sends out one message. You hit function key 11, send out a different message. Now, if you send out 7, how does it know it's a local or an accessory 7? Well, that's inside the actual packet, that the DCC packet that's sent. There's a piece that says, by the way, this is a message for a local, or this is a message for an accessory. And those flags are picked up by the relative decoders to know it's for them. They come in general formats of a pulsed pair. In other words, the decoder has got 2 output pins, and then they go to a common via the coils. So you pulse one pin to move the point one way, pulse the other pin to move the other direction. So they are pulsed type outputs. You also get steady outputs. For example, for a tortoise, where you want to simply make the 2 pins have one polarity to go in one direction or another polarity to go in the opposite direction. And that directional output, or bidirectional output rather, also allows you to have 2 aspects signaled instead of tortoise motors. So you wire a red and a lead, red reverse wiring, and you bring one on or the other. And then finally, there's decoder outputs with single outputs designed for just bringing on one lead or connecting to relays or servo controllers, that kind of thing. So these are all available commercially at a price. There's one there, there's 6 solenoids for 54 quid. It can handle both motorized, in other words, tortoise ones, or solenoid at a price. DCCdecoders.com do a 4 output one for 24 euros. Bit cheaper. Merg do them too. Merg do kits that either control solenoids or tortoise motors or I/O. There's no DCC kit for operating servers directly from Merg. The picture that I'm showing here is kit 52 from the kit locker, and it operates 4 solenoid pairs. In other words, those 2 are going to operate one solenoid by either making one conduct or the other through the coil of the solenoid. There's the second pair, the third pair, and the fourth pair. They also do a kit 53, which also has 8 outputs, but can be configured to operate a tortoise. In other words, a constant on as opposed to pulses. Or you have the option to have it as 8 I/O instead. 8 outputs, rather. I shouldn't have said I/O. It should be 8 outputs or tortoise. There's how they work. You can see the pick down here, power transistors, and there's a common that says 12 volts that comes along to here. If I then put a solenoid coil between there and there, and another one between there and there, I can then switch to conduct one transistor or the other. And they'll pass current through there, or we'll pass current through there to operate the point. Or if we want it to be output only, we can just put a bridge across there and take your reading from here. So you can get output only, or you can get a solenoid using, and there's a second pair, third pair, and a fourth pair. Now, DCC decoders receive messages, and they have to come from some kind of DCC controller, generally speaking, your DCC command station in most cases. For those with deep enough pockets, then these men have a brilliant command station that has got an on-screen display. In fact, several displays, because if you get a large enough layout, it wouldn't all fit on that particular screen. So you can then move between alternate screens to see different parts of the layout at any one time. So you can control your layout, and you can operate your accessories for only $835. If you prefer, you can have the handset I mentioned earlier. The handset connects, generally speaking, to a DCC controller, or in this case, from the NCE into a booster. And you have a hand cable, and that lets you walk around the layout to some extent as far as the cable will take you. So for a larger layout, you can walk around. 166 for the handset, extra when you want the booster, of course. Here's another version, a bit cheaper, from Gauge Master. Doesn't have the on-screen facilities, etc., but you've got yourself the controller and the handset and the connecting cable. You can get wireless versions as well as wired versions. And that lets you completely walk around your layout unfettered by a cable. If you want to connect to a command station via computer, then you can use phones or tablets. You install one of many options of software. That's just the 3 of the most common ones. You install the software on your phone. The phone then talks to your computer via Wi-Fi. The computer then connects to your command station and then sends the various messages onto the track, if you like that method. Personal choice. The pros and cons of that is it lets you walk about. There's lots of offerings in software, and usually free. Downside is it needs Wi-Fi. And it can be fiddly to set up if you're not an experienced user. And you're even fiddlier jumping around using the software, having to remember which function for each point and so on. And there's no feedback, of course, it's one way only. And then there's computer control, where you can talk to the computer if you wish, and the computer then talks to the command station. Like I said earlier, a glass panel where you can touch parts of the screen with your mouse to operate, or maybe a touch panel to operate various accessories. Or you may want to go down the full automation route, or somewhere in between, a partial automation, that you're doing the shunting in the shunting yard while you've automated the main lines, for example. There are various commercial options, but JMRI and Rockrail seem to lead the field in the free options. And there's members on here today who'll know more than me about how to use JMRI. But basically, you have the Panel Pro, where you can actually have a panel editor like we have in the top here, or you can have a layout editor where you actually have a graphic representation of your layout. So the Panel Pro, very flexible software if you want to go down the computer route. Software's free. You can create complex operations because you can have feedback and all kinds of logic, and automation itself can be handy if you're an exhibitor. So it lets things happen to guarantee there's always activity for the public to see. The downside, you need a computer to operate it. As soon as you take the computer away, it stops working. There's definitely a learning curve if you're prepared to tackle it. And it may involve some script writing if you're trying to do some fancy stuff. And of course, if you're operating from a glass panel, you can't move around because the whole idea is you're sitting at a computer with your mouse. So depends what you're looking for. At one point, Merck had a kit 51. It's no longer produced, which is to my mind is a shame, because what we have here are the other two kits, kit 52 and kit 53, showing connecting to a solenoid or connecting to whatever, tortoises or lights or whatever. And the idea was, let's not have with traction and the accessories on the same DCC bus. Let's have one bus for traction as normal and put in a second 2 wires run round the layout to handle accessories. So get 2 buses completely operating independently, and you have an accessory decoder, and in there you can just see a large connector that you can take to a matrix of switches, and those switches then can be on your control panel. So you're handling this as a completely separate outfit from the rest of the DCC. The benefit being you're not having to use your command station, you're using this accessory decoder to create the messages. So it'll work independent of traction. Or put another way, if you have a derailment or whatever, the whole business doesn't hang up because your accessories and the points and so on are operating independent of the traction. For some reason, it became out of favour. I don't know why, because it seemed like a useful tool to me. It does raise a question about fault liability, though, because if you've got the one track coming along and that does traction and every single accessory you've got in the system, all your eggs on one basket, that says there. If one thing goes faulty, the whole thing stops. If you get one faulty module which hangs up the bus, or you get a derailment which shorts across the track, which is also the bus, of course, then where is the fault and how do you cure it? And luckily, that's where MERD come in with a district cutout. Because what they say is, well, why don't we, instead of having the command stations feeding the entire track, which is the normal, let's cut them into zones, isolate each section, and have each section through a district cutout. So if you divide your layout, say, into 5 sections, if you get a fault in one section, the other 4 still carry on. Because they're independent, the cutout has stopped the bus from being affected by what happened in that particular zone. Which is very handy for exhibitions because you don't bring everything to a halt. You can still have operations going while you find out what's happening in that particular power district. DCC in general, then, the pros are you've already got the wiring. Generally speaking, it's simple to use once it's set up. Easy to understand, and no computer required. You're using your command station. So you have most of the hardware and the bus already existing. Downside, it can be an expensive option. It can take time to set the thing up, especially if they're using GMRI or whatever. Some of the modules you get commercially don't offer server support. And then the last one, it's just a personal one. I'm called it fiddly jumping around. What I mean by that is, I don't like a panel, an iPad or a tablet or a phone, and you have to remember that point is actually point function 17. And now I've got to do move that point, and that's function 21. It seems a strange way to operate a layout, nowhere near prototypical, but a lot of people like it. Personally, I'm much happier with a control panel with switches with a mimic of the whole layout. But that's could be a con if you agree with me, basically. So that's the DCC decoders. There's now one brought out by just recently by DCC Concepts called the Alpha Mimic Plug and Play Controllable Building Lighting module. Here's a mouthful. And they advertise it as handling 24 lights at 75 quid. It's a lot of money, but I think it's a bit misleading about the 24 lights. Let's just have a look. You can see there, yep, okay, we've got a place for the power coming in, we've got a place for the DCC coming in, and we've got a whole bunch of outputs. And there are 24 different pins there. Sounds okay. And you're going to operate them using your command station again, hitting function key, whatever it is for that particular output. If you like that, fine. The pros are no construction. It's already built. You just take it out of the box. No computer. And here's the confusing bit. Although there are 24 pins, you only have 12 lights. Because any of those 2 pins either goes high or low and high. And you put your lead across it, and you put another lead again, reverse wired, say red and green. And if you throw the function one way, the red comes on, throw the function the other way, the green comes on. It needs 2 pins, so you're allocating 2 for every lead. So in actual fact, it's 12 sets of 2. It's not really 24 separate LEDs. Just the way they've worded it is a bit misleading and maybe a bit unfair, I think, possibly, right? So it's only 12 pairs you get. And the outputs I should have mentioned I went onto the website because normally they're very good at doing documentation, but the documentation for this isn't up yet. What they do have in one of their bulletins is links to YouTube appraisals of it. So the stuff I'm talking about here is what I've seen from the YouTube videos. And they claim that each pair can handle 20 milliamps output. And they recommend to have no more than 2 LEDs in any one output. So right away that says, oh, what if I want to light up an entire station or an entire street lights or a big factory and so on? I've only got 2 LEDs in any one output. So that's right, without additional circuitry. The other downside is it doesn't handle servers, only for LEDs. In the meantime, you could use optocouplers, of course, but again, that's back to what I mentioned before, additional circuitry to allow you to do different things with that same module. My opinion is a bit limited, but and fairly expensive. We've got to then add on extra easy points or servo 4s or whatever into the mix. And it brings up the question about how many is too much. Most modules tend to work on 6 or usually 8 as the optimum figure. This kit here comes, you can see there, with 1 meter or 4 feet, I can't remember, of wire for each LED. They supply LEDs with it. And they then supply, or you can buy extra extension leads to get another 4 feet. In other words, they're expected to have this module feeding a light 8 feet in one direction, 8 feet in the other direction. And it takes away, in my opinion, the whole point of having a bus. The whole idea of a bus is activity that's local comes from one module. Activity somewhere else comes from another module. If you've got to end up having a module in the middle of the layout that goes everywhere else, they may as well come from the control panel. What have you gained if you're having to go all over the place? Right? So having 12 might be okay in certain places. But often you won't be using them all. Most people pick 8 because that handily is 1 byte of information. That seems the most common. So that's the VCC concepts one. Now, other people like to operate their layout either from a control panel that you see there, or from a lever frame. So what you need to do is be able to wire these switches somehow, or these levers with micro switches somehow into a module, because you're tied to a fixed place. You're not walking around. The lever frame's on the layout, as is your control panel. Luckily, the 3 MERG systems all support that. The EasyBus, peer-to-peer light, and CBus all are able to handle control panels and lever frames. And lastly, I want to look at mega points, but it's not the one that you see sold in our kit locker. The one in our kit locker is simply a bunch of switches and a bunch of servo outputs. It's not really a bus-based system. They also do one called multi-panel, which uses the I2C for switches and LEDs. But what I want to look at finally is the one they brought out very recently. New for 2023, the System 2 from Megapoints. Not sold in the kit locker, but sold through Megapoints themselves. The starter set comes in at £200, and that gives you one master board and a servo board and a relay board. Now, there's the control panel, costs 60 quid. It's got 16 inputs down the bottom here, and it's got 16 outputs at the top here. Now this is 16 pairs. You can see there's 3 wires here, the normal and the complementary and the common. So it can handle 32 leads, but they don't advertise it that way. They're more honest. The big feature of this is, as you can see, you configure it using Wi-Fi. There are no switches, there are no push buttons. You configure it using Wi-Fi. It's designed for mimic panels, hence the bunch of inputs down here for switches and push buttons. Although it says you could put in totties and block detectors as inputs if you wished. But its main feature is Wi-Fi configuration. Pretty flexible in terms of inputs. It can handle your normal switches or your toggles or various sensors, and you can have reversing output to switch 1 or 2 LEDs. That's the control panel. The relay driver, for £68, you get 8 relays. Again, configurable with Wi-Fi. What do you want to configure? It's just a relay. Well, what you might want to configure is things like you can have coming on and off permanently, or you can have it pulsed. Bring the relay on any time between 50 milliseconds and a minute. So you get a long pulse if you wish to play mute audio or something. So the output is configurable, hence the need to configure it with Wi-Fi. Your normal 12-volt connector, and then your outputs. And then a servo driver. 8 servos, back to the optimum again, 44 quid. 5 of each, not counting the servos. Again, you configure it using Wi-Fi. Things like the speed of the servo and the end points, and whether you want bounce. So it's got a good number of features that you might find interesting. Now, the pros for that, they're already built. The pros for that is, once you've got it working, you don't need a computer. You do need Wi-Fi to get it set up, but after that, it runs by itself. It can handle a huge number of devices, and it's ideal for control panels and lever frame use. Downside is it's expensive. It's using a CAN bus. It's not the C bus. It's not Merck's C bus. It's another version of the actual original CAN bus. Again, you may have noticed that it supports relays and it supports servos, but doesn't have ordinary logic outputs. Again, I contacted them and they said they intend in bringing out a new module that will give you digital outputs. And if you're not happy with using a computer, you won't be too happy with using this, because the setup for using Wi-Fi is 14 pages long. So it's relatively complex to set up. but it's easy to, once you've got it set up, to alter afterwards. So that's the review of the commercial ones. I haven't looked at the cost, because what I'll do in part 2 is I'll look at the Merg offerings, and then I'll work out if the layout for, say, a layout for 24 points, what would it cost you to do it in each? If you had a layout with 60 accessories, what would the cost be to do it? And we can compare a bit like with for costs. But in terms of functionality, that's what the commercial ones currently offer. Any questions, comments, or suggestions?